Okay. So let's see. So I'm gonna split the screen like side by side. One screen has the tutorial file, and the other screen has the Linux Windows. So you can see like what step I'm in at. So let's see. So the first step is to download the PDK. Anyone download the PDK yet?
Yeah, I have. But a quick question, can we also go through the Tiger VNC setup if we can quickly?
Okay, so I guess like on so you haven't used VNC before, right?
Not Tiger VNC, so it's a bit
Oh,
confusing.
okay. So let me see. Yeah, so
actually any VNC is fine. I also don't use Tiger VNC and other VNC.
yeah, okay. So let me start with that then. So let me close this one. Yeah, so let me that's it. Okay, so you can, if you're using Windows, you can go to here and then search for command command prompt, and basically it's gonna show you like the sort of command you can use to execute functions. And so you first of all before you want to like access the Windows I just showed you before, you have to SSH to the computer in the lab first. So so this one, let me see.
I see.
Yeah, this one is a command you just need to type in order to SSH to the computer in the lab. So SSH -C, capital C dash capital L, and 5910. So this one is 5910 colon localhost 5910. This one is doing a port forwarding for you. So let me see. So this will allow you to basically like put it in a simple way. It will allow you to like to use the visualization of Tiger VNC. And then you type your Columbia ID and then add remote 01.ee.columbia.edu. And so you need to type your password.
I get something called bad local forwarding specification. Maybe I'm doing something wrong.
But can you access to the computer yet?
Oh, the other thing, because I was, sorry, the other thing is like, because I was a little saying this up yesterday, is that the IT, like the electrical engineering IT, actually they reset the password for those machines like during the summer. So your password might not be the same.
I see.
Yes, I don't know exactly what exactly the error you're getting. If you want to screen share or something, maybe.
Maybe I can stop sharing my screen and you can share your screen. If that makes sense. You want to do it?
Yeah, I can try. Okay, so participant screen sharing is currently disabled.
Give me one. Okay, you can do it now.
Okay. Yeah, so this is my command prompt. And this is what I currently have.
It's remote 01.
Yeah, you are remote 001. So you are having, yeah.
Extra 0, okay.
Yes. Type, you can type yes.
Okay, I see. Okay, I think I'm in now. Is the password that we use to sign into our Columbia uni?
Yeah.
Is this the first time you use the machine or like?
Yeah, the first time.
Oh, there's a instruction for like first timer setup thing. They need to actually follow that.
I see.
I think you can actually set a different password, but I honestly don't. You have to remember. You might be stuck on the first timer thing. Yeah.
Okay. So I'll actually try this and email you if I can't figure it out. I think that would be.
You should
Okay.
email the electrical engineering IT. They're like super fast. They respond like in 1 minute.
Okay. Okay. That sounds good.
Yeah.
Thanks. Okay. I'll stop share.
Okay. But have you ever access to a computer in the lab?
No, I haven't.
Okay, so
The other thing you can try, because I actually realized that the remote machine has like 1 day delay of like updating the password. You can come to the
Mhm.
lab and then try to do in person first and see whether you can log in. If you can log in, then your password is correct, and then you try to log in on your remote. And then if you cannot log into the lab machine, then you should email the IT saying that your password is not yeah. If
I
you
see.
have
I
a
see.
like a
Okay.
24-hour delay for like updating your password, I think.
yeah,
Okay. Okay. Got it.
it was a while for me, so I don't remember exactly the details.
Yeah.
Yeah. So maybe you can.
Thanks for the advice. Yeah, I will try it. I think I have to fully follow the lab remote access instructional from top to bottom once, and then
Yeah. That's okay. But can you access to Cadence?
I cannot, unfortunately. I don't think I can.
Okay.
Is Cadence actually installed in your lab machine, or do you have to install it yourself?
Are you asking me?
Yeah.
So that's what you are talking about Cadence. Oh, which one?
Oh no, I was just asking because I actually installed Cadence like last semester, I think. So I was just wondering whether Cadence is like something like just on the machine that I could just like bring up, or you actually have to install the Cadence first. I install the version.
So you Cadence is already installed in the lab computer. So you
Okay.
can always use from that. You don't need to install Cadence in
Oh,
the
okay.
computer.
I see.
Okay, let me share my screen. You guys see my screen, right?
Yeah.
yeah.
So let's see. So have you downloaded the PDK yet? Yes, no.
Yeah, yeah.
Okay. So and then you use this command to extract this one is like I basically we download like a tar file, and we need to extract this tar file, and so we type this command. I already extract the file already, so I don't need to do it. But yeah, you can just use this command to extract the file. And then so the next step is we need to refer Cadence library to this PDK file by editing the cds.lib file. But there's it's like more simple way to do it, which is we just need to open Cadence first. So you type virtuoso. First of all, you need to go to the Cadence library, Cadence folder, and then you type virtuoso. Wait, sorry, I should not do it this way. So okay, so I can access the lab computer using Tiger VNC, so it's easier to see with Tiger VNC. So connect. Hmm. Okay, so Okay, so in here we are forwarding the port 5910 from our computer to the port in the lab computer, which also 5910. So in here we can now we can type localhost 5910 in order to access the lab computer from BNC. Then it asks me for the password. Okay, so in here I already opened Cadence. So from Cadence, you can open your library manager. So it show you all the libraries you can currently have in your computer in the lab. And so in here we I already add the library called reference 90 RF, which is the PDK we're gonna use. But in order to see the library in here, I would need to so before, if I don't do anything, there's no reference 90 RF library in here. So if I want to add it into the library manager, I would need to go to so in here you go to tools and you go to library path editor. Let's see, yeah. So in here you have two columns. The first column is library name, and the second column is the path where Cadence is gonna go to the path to find the library. And so let's see, reference. Yeah, so in here you can see like I have a line where the library is reference 90 RF, and the path is the tar file I already extracted, and so this is the path I refer Cadence so that Cadence can go to this path to find the reference 90 RF library. And so basically, if we type the library in the path in here, we are done with this step. Okay, and so we start the virtuoso, and then we are in a step 5 where we need to create a library, and we attach the 90 RF PDK to that library. Oh, by the way, when I'm doing this, anyone like following using Cadence? Hello.
Sorry, what was the question?
So while I'm doing this, are you using Cadence and follow with me, or you are just observing?
I'm just observing.
Okay. That's okay. I record the file, so you can follow later. And so so like I'm gonna create a new library. Library. Let me see. So let me call it ELEN6320 and homework. And so in here, you would need to select attach to existing technology library. And you select reference 90 RF. Okay, so we are done with this step 5. Yeah, and then we choose a reference media for technology attachment. And so we have the new library. Let me see. Yeah. Okay, and then we are gonna create a schematic where we can test the transistor. So cell view. Okay, yeah, and we type you can name like whatever cells name you want, but I just follow the tutorial. Okay. Okay, so we are at step 8 where we gonna instantiate like NMOS for analog bit. So we can like in an ideal scenario we can use a transistor in the PDK, but the thing is that model that PDK is not like there's something wrong with the model in that file in that PDK, so we cannot use the transistor in that library. So we're gonna use the transistor in the analog bit. And was for so this step is important. You would need to name your model name in here and so name field and enter the length of 100 nanometer to the width and width of transistor. So the width is one micron and length is 100 nanometer. Okay, I'll put it here. And so we are in step 9 where we build this schematic. I cannot do it very quickly. So in here we are trying to plot the F max of. We are trying to find the F max of the transistor in this PDK, and in order to do that, we need to build a BIST network, which is shown in this schematic. And the purpose of the BIST network is you can plot the Gmax, which is the maximum gain the transistor can provide from input to output. And so like the higher the frequency, the lower the Gmax, the lower the gain the transistor can obtain. And so when Gmax reach 0 dB, which is like the transistor cannot no longer provide any gain, we at that point we can get Fmax. So in order to find Gmax, we need to have a 2-port network. 0.1. And in here we can see we use very large capacitor and inductor, and the reason why we use a very large capacitor, which is like in here like 1 femto, 1 farad, and the inductor is like 1 Henry, is that at high frequency, the capacitor act like a short circuit and the inductor act like an open circuit. So the DC doesn't affect the signal at high frequency. So one inductor. Okay, so I just duplicate the schematic shown in the tutorial. So the next step, which is step 10, is to launch ADE and launch ADE. Let me just close. Trying to check lesson. Okay, let's try all of these. Okay, so in here we have an NMOS for analog, NMOS for model from analog clip. So if we run cadence with this test bench, cadence like doesn't know the parameters of this NMOS for model, and so what we need to do is we need to refer this NMOS for model to the 90 nanometers model we have. And in order to do that, we need to go to session. Oh, I'm sorry, setup, and we choose model libraries. And in here, I already have some model I created in the past, but for this course, I'm gonna disable them, and I'm gonna add the model file. So what I'm doing is repeating step 11. So we need to find the file reference model.inc in the PDK we just extracted. Let me see. Because I have so many files I need to find. Okay. Cadence. So much, Yeah, so here's a model file I need to refer to. So reference model .inc. And so that is for step 11. Okay, and then we need to specify the VDS and the VGS voltage we have in the schematic. And in here we set VDS to 1 volts and VGS to also 1 volts. 1 and 1. And so in order to find the Gmax of the transistor, we need to do an SP simulations. So in the analysis, select edit, select SP, and we need to select port 1, port 0 and port 1. So port 0 and port 1. And we're gonna sweep the frequency range in here from 1 gig to 1 terahertz. And so sweep range, we start from 1 gigahertz and stop at 1 terahertz. And we select the sweep type is logarithmic, and the point per decade is 100. Looks like we have all the setting duplicated. Okay. Okay, so now we have the SP simulations. We need to run the simulation. I think the simulation is finished. Oh, okay, it is still running. So whenever you run simulations, it's gonna spit out a log file. And if you want to know like how cadence work, like where it go to find the duplicate file, you can see this log file. It contains a lot of like useful information in case you got stuck in some step in simulations. And so when we're done with simulations, we're gonna plot the result. And so we go to a result tab, select direct plot, and main form. So in here we have a lot of like options we can choose. For example, if you design an LNA, you would want to plot the NF mean, for example, or G mean. But in here we're gonna plot Gmax. And so we want to plot in dB10. Check the output and select plot. Let's see. So we have something in here, but it doesn't look like the pretty graph we have in the tutorial. So in order to do that, you would need to double click on the horizontal axis, and see, you go to scale and auto scale, and you select log. Okay, so basically you plot frequencies of the horizontal axis in log scale. And so you can see like the Gmax versus frequency, like it, for example, at 1 gigahertz, you have Gmax of 26 dB. But let's say at, I don't know, like 500 gigahertz, like the Gmax you can have is only 1.8 dB. And so let's see, so the plot showing the Gmax of 60 gigahertz. So let me try that. So in order to plot the vertical marker, you press V on the keyboard, and you type 60 gigahertz in exposition. So yeah, we have like 9.1 dB. They have 9.8 dB. So the PDK, the model might be slightly different. Yeah, we have we can plot the Gmax at 60 gigahertz. And yeah, I think that is the end of the tutorial. So I cannot stop recording now, but if you have any questions about technology access, just then you can email me like later, or you can ask me now.
But you said the S parameter is like slightly different because the library is different, basically.
This one, right?
Yeah, it's like 9.8 versus like 9.1 something, and that's because the library is different.
Yeah. So the thing is, when they create the tutorial, it was like 2016. So they probably use a different, like slightly different PDK at that time.
Is PDK just library or?
So yeah, PDK is the let's see, it basically, you can imagine it's a folder that has like documentations,
Okay.
models, model libraries,
I see, I see.
RCA,
Okay.
RFFlow.
Sure, sounds good. Thank you.
Finish, stop, finish. Okay, so stop recording.